Hello guys, namaste, Barev. Anyway, here we have a capacitor. It's lesson number 10 or 11, if I'm not mistaken. But anyway, here we'll cover more basic of capacitor, and we'll go deep as well. Capacitors, they come in different forms. First, we have ceramic capacitors, and we have lithium capacitors. We have electrolytic capacitors, and what else? What other capacitors do we have? We have just different types of capacitors, and depending on the function, and because they do different things. But here, this one we are covering here, it's for now it's just a capacitor. Let's see what are capacitors. Capacitors are components that store charge. Yes, capacitors, they store charge. They act like a battery, more like a battery, but not much charge, and this charge, it doesn't last. Okay, it doesn't last, unlike a battery charge lasts for a long time, but capacitors, it doesn't last. And some capacitors, the charge is only stored when the machine is on. Now once the machine is off, the charge discharges. So it depends on the type of capacitor. So let's go ahead, let's see what exactly we have. Okay, so normally this is a capacitor, a sign of a capacitor. All right, so a capacitor, especially ceramic capacitor, would be like this. We have positive and we have negative, and there is a gap in between. I hope you can see those two lines. They don't touch at all, at all, at all, at all. But if there's a short, they will touch, and the positive will go stay straight to ground only if there is a short. But normally they don't touch. Even when you are checking a capacitor, there shouldn't be any continuity at all when you are using multimeter. When you are using a multimeter, there shouldn't be any continuity at all because they don't touch. There is a gap in between. Right, let's continue. So the charge are stored. Normally there are plates inside capacitor. All right, so this is very important. They're saying the positive and the negative charges are equally and are opposite, so they are stored equally to both sides. What else? This is a sign of a ceramic capacitor and the sign of a electrolytic capacitor. Anyway, this is what's a ceramic capacitor, and this is a sign of a ceramic capacitor. Those brown things that you see on the board, they are what? Ceramic capacitors. And these ones, you can't say they store charge. They don't store charge if I'm correctly, but they normally rectify the flow of electricity. They smooth out the power. They are very important to stabilize everything. And the symbol for them, it's C. And for power capacitor, it's called PC. For normal capacitors, you will find C. These are ceramic capacitors. When they short, they normally track. You'll see them track. They normally track. I've done several videos explaining how they get shorted. I've even took one and I tracked them. And yeah. So this one are electrolytic capacitors which store charge. This one they store charge. All right, and they'll show you a capacitor which can store up to a maximum of 50 volts, but only specifically this one, the one you see on the picture, because you'll see 50 volts there. Anyway, these ones, let me go back here. This one, when you are installing them, you can use any side. They don't have any polarity. All right, you can just put them at any side, but this one, they have a polarity, so you have to be very careful when you are placing them. You have to put them, you have to put ground where there's ground and positive where there's positive. Very careful when you are replacing these capacitors, and when you are replacing them, you should use exactly the same value. For example, this one is 470 microfarads, so it means you will have to find another 470 microfarad volts. You can use 100 volts, but make sure it's not less than 50 volts, because this one, it needs 50 volts upward. So you have to make sure that on the board you use 470 microfarads but make sure it's more than 50 volts or it's 50 volts exactly. If you can't find 50 volts exactly, you can use 75 volts, 100 volts, 150 volts. You can use any value, but make sure it's not less than 50 volts. And with microfarads, you have to be very specific here. You have to use exactly the same value, which is 470 microfarads. Okay. And the capacitance is measured in farads. So that's why we call them microfarads, because we're using microfarads here. So guys, on code tip, these are SMT capacitors, electrolytic capacitors, and this is a titanium capacitors. These are titanium capacitors, and these are knock-token capacitors. These are old ones we used long time ago, and they always had some issues. Let's talk about these ones, the silver ones. These are SMT electrolytic capacitors. This one normally, when they go bad, you will see some white stuff around them. And this one is very hard to find. Otherwise, they will pop up a little bit, but it's very hard to tell if they are shorted or not, including this one, this old net token as well. All right. Okay, these are capacitors. Oh yeah. Oh yeah. Oh yeah. Oh yes, this is how you measure. You measure them. Measure those capacitors. You can put black prop to ground. The ground USB connectors. Put one black prop there, and then with one prop you charge one side of the capacitor and charge the other one. We have to check whether it's connected to ground or not. The ground. This is the ground. Even the screw holes are ground. Even the heat sink hole that's ground. You can use the ground, and then once one prop to ground, of which is black prop and the positive prop, you touch the sides of the ceramic capacitor. You check for dots. Okay. And capacitors. Let's go back here and I'll show you something. So here, if there's a short here, where will you check for a short? Obviously, you will have to check these capacitors because they are the only thing connected to ground. You have to understand the entire. They are not directly connected, but they have one side of their capacitors is connected to ground. So if it gets shorted, it end up allowing the main power rail touching the ground. Oh yes. Okay, even here as well on this circuit as well, if there's a short here within this thing, obvious, you will check PC5 and check PC7 and check PC6. One of them will be grounded if there's a short. As you can see, even here they're showing you how to check for a short. Oh, okay. They almost did the same example I was doing. So the 19 volt will flow here, meaning the short is not here and it's not here, but it's directly here. Exactly what I was telling you. This is how you check the capacitors. If it's barbs like if it's bars like this, it means it. But one more thing, the tricky part is if this one is shorted, all of them they will act as if they are shorted. So you will have to be very careful when you are checking for shorted ceramic capacitors. That's why we use a DC bench power supply to inject the volts, a specific voltage, and then the shorted cap will get what? You check them. All right. Anyway, I'm done with capacitors. We'll cover what? We'll cover another topic on my next video. Anyway, bye bye guys. I love you so much.